So today I will discuss the very important chapter, another important chapter of matrix, that is inverse of matrix. Now inverse of matrix, as you know in the numbers, like if you have a number 5, then there is a number in such a way that product of these two will be 1. So you will say that 1 by 5 is multiplicative inverse of 5. Now in the matrix, if you have A, I is same as 1 in the matrix. Okay, so here suppose you have another matrix B in such a way that the product of these two is equals to I, and also it is also equals to B into A. So this B is known as inverse of A, or it can be written as A inverse. Now here we cannot write this B as 1 by A, so instead of writing 1 by A, we used to write it A inverse. Okay, so now this is the condition that if the product of two matrix is equal in such a way that AB is equals to BA and that is equals to I, then this B is the inverse of A, and you can also, reverse is also true, that BA will be the inverse of B. Now how can we find out the inverse? Now you know that A can be written as IA and also A can be written as AI. Both are true. Now what we will do here, we will change something in this A, and the same changes we will do in this I, and we will try to make this A as I. So we will try to make this equation is in this form, like I equals to A. Some changes will be done here, so it will not remain I, it will change to B. Okay, so now this B will be the inverse of A and this A will remain same. So this is the process actually, and how we will do this. For doing this, we have some elementary operations, that operations and I will discuss. Now here in the elementary operations, we can do these in the rows as well as in columns. Okay, so the first one is interchanging rows or column. Interchanging rows and column means, suppose in a matrix A, we have a row. Now we can interchange the rows in this particular matrix. So that is, suppose if we are changing this R1 with R2, so this matrix will reduce to, here see, this is your R1 and this is your R2. So in the place of R1 we can write the R2, so it will be 2 3 4, and here it will be 1 2 3, and 5 6 7 will come as it is. The same way in the above matrix, if I change the column 2, I am interchanging the C2 with C3. So here this matrix will reduce to, see here, this is your C2 and this is your C3. So in the place of C3 I will write C2, in the place of C1 C2 I will write C3. So see here I've written the C2 and this is your C3. So after interchanging you will get this matrix. Okay, so next one is elements of the rows or columns can be multiplied with any non-zero number. So we will see this one. Suppose we have A, so according to that, first I will apply it in a row and then I'll show it in a column. Okay, so here I'm replacing the R1 with twice of R1. Okay, so I have multiplied the R1 with 2. 2 is a non-zero number. So this, after doing this change, what we will get, the first row will be multiplied with 2. So it will be 2 4 6, and other row will remain same. Now this thing can be done in a column as well. So C2, I'm changing this C2 with thrice of C2. Okay, so here after doing this change, it will become these C1 and C3 will remain same, only this will reduce to 6, 15, and here you will get 6. So like this second operation you can do in the. Now the next one is, next elementary operation is, the elements of a row or a column can be added with the corresponding elements of another row which is multiplied by a non-zero number. Okay, what does that mean? Means in the previous we have seen that we can interchange and we can multiply also. So here you can replace any row, like R1 can be written as R1 plus any non-zero number you can take. Suppose I am taking 2 here with R2. So that means my row 1 will change with R1 plus 2 into R2, means the corresponding elements of R2 I will multiply it with 2 and then I will add with R1. So this is your R2, so I will multiply this R2 with 2 and then I will add up this with R1. So after doing this, what we will get, this will result, our R1 will be 1 plus, see this one, 3 into 2, 6, 2 plus 2 into 2 plus 0 plus 2 into 1, and the other 2 rows will come as it is. This one is clear. R1, first we will write the elements of R1 as it is, 1, 2 and 0. Then this second row we are multiplying with 2 and we will add the corresponding elements. So it is 2 into 3, 6, 2 into 2, 4, 2 into 1, 1, 2 into 2, okay, 2 into 1, 2. So here this matrix will become 7, 6, 2, and the remaining 2 rows will come as it is. So this is the third elementary operation. Now same thing, you can proceed with the column also. Here suppose I am writing this C2 as C2 plus 3 C3. Okay, so now after doing this, what we will get here, this C1 will remain same. In the place of C2, what we will get, 2 plus the C3 is multiplied with 3 and then added with that. So it is 0 into 3, 2 plus 1 into 3, 1 plus 2 into 3, and the third column will come as it is. And simplify this, so you will get, after this elementary operation, it will become 1, 3, 1, 2, 5, 7, and the third will come as it is. So these are the 3 elementary operations. Using these 3, we can find out the inverse of a matrix. Now let's see how can we find out the inverse. Okay, so look at this one. Here we have A equals to IA. A can be written as IA as I told before, and A can be also written as AI, IA or AI. Now here, what you have to do, in the left side, so you will write A, okay, and the right side, you don't have to write A again. Leave the A as it is, only you will write the I. Here also same, A only you will write in the left side, and the right side A you will remain, you don't have to write that one, you will write I. So what is the process exactly? The process is, we will do the changes. 3 elementary operations we have, I've told you now. So these 3 elementary operations we will do here. So whatever changes we will do in this matrix, same changes we will do in this I. Okay. Now when you have written in this way, here you can see first one. First, here I is written in the first. So here in this type of arrangement, you can only do row operations. No other operations can be done. Like in this type of arrangement, you cannot do the column operations. So in this only you will do the row operation. Like in this, you can see A we have written here. The identity element is in the second here. So here in this type of, we can do the column matrix, column operations only. This thing is clear. This is very important. And after that you can find out